Automating workflows today isn't just a nice to have, it is essential. Businesses and developers work with multiple apps, APIs, and data sources. Connecting and coordinating them manually can be slow and difficult at times to scale. Well, this is exactly where n8n makes a difference. It simplifies this complexity by enabling you to connect applications, move data, and trigger processes in real time, giving you a full control over your infrastructure. Hello everyone, I'm Sanskriti Harmak, a developer relations at Vultr, and in today's Tech Talk, we will explore what n8n is, understand its core capabilities, and conclude with a hands-on demo running automated processes on n8n instance on Vultr. So, without any further ado, let's get started. Before we jump into the demo, it's important to understand what n8n actually is. N8n is an open source fair code workflow automation platform giving you full transparency, control over the code, and the ability to modify or extend it without vendor lock-in. At its core, N8n provides a visual drag and drop node based interface where each node represents an action or a connection to an API or service, making it easy to connect apps, transform data, and automate processes without heavy coding. You can either self-host N8n on your own infrastructure or use their cloud offering. Self-hosting gives you complete control over your data, security, and compliance, while the cloud option handles scaling and maintenance for you. Finally, N8n comes with over 500 native integrations, and if that's not enough, you can always extend it with custom nodes and code. Now let's talk about why you would want to use N8n. Perhaps the most compelling feature is its ability to automate multi-step processes across diverse systems. Rather than manually moving data between apps, N8n executes every step automatically, reducing errors and saving time. Self-hosting N8n ensures complete data sovereignty and privacy, which is critical for sensitive workloads. Whether you're automating a few workflows or running high-volume processes, costs remain predictable and scalable compared to proprietary platforms with restrictive limits. N8n is also highly extensible. You can introduce custom logic, write scripts, or even integrate AI agents into workflows, enabling automation that evolves with your business needs. Next, let's look at some practical use cases. One common scenario is streamlining lead capture and CRM updates. Instead of manually copying form submissions into your CRM, N8n can automatically capture, format, and route the data. IT operations and monitoring are another area. You can automate incident alerts, system checks, or ticket creation, ensuring your team responds as quickly as possible. N8n also powers advanced business processes. With AI and human in the loop workflows, it can handle tasks that require conditional logic or complex decision making. Lastly, embedding N8n directly into products or backends allows you to offer workflow automation features natively in applications, connecting APIs and services seamlessly behind the scenes. Now that we have covered the core concepts of N8n, let's move on to the demo. First, we'll deploy N8n on a Vultr Cloud Compute instance, secure it with a custom domain, and explore the exposed dashboard. After that, we'll create a sample workflow that captures form submissions via Webhook, formats the incoming data, and sends notification automatically. This will give us a clear view of how N8n handles real-time workflow automation in a self-hosted environment. Before we begin, let's confirm that all of our prerequisites are in place. I already have an Ubuntu 24.04 cloud compute instance running on Vultr, which will serve as our self-hosting environment. This instance is reachable via custom domain name, as the required A records already points to the server's public IP address. You can configure this through the domain settings in your domain registrar or via Vultr DNS. Apart from these, please ensure that Docker and Docker Compose are installed and configured in your workstation so that container runtime and orchestration layer are ready to proceed with. The instructions to achieve these are outlined in the supporting reference guide linked in the description. With that foundation set, let's start by creating a directory structure to hold our n8n configuration and persistent data. This ensures that even if our container is recreated or updated, our workflows remain intact. We'll create a main directory called n8n and within it two subdirectories, one for n8n's data and another for any local files we may need. Since the n8n container runs with a user ID of 1000, we need to make sure that the directories have the correct ownership. This allows that the container can read and write data without permission issues. Now our environment is prepared to deploy the n8n container with proper paths and permissions for persistent storage. Next, we'll define the Docker Compose configuration for n8n. Using Docker Compose makes it easier to manage the container, environment variables, persistent storage, and networking all in a single file. Inside this file, we define a single service for n8n. We are using the latest n8n image and naming the container n8n. The restart unless stopped policy ensures that the container automatically restarts if it crashes or if the server reboots. Further, we map the port 5678 on the host to 5678 in the container. Then we set environment variables to configure the host, protocol, webhook URL, editor-based URL, and time zone. Notice that n8n user folder points to the user directory inside the container, which is where n8n stores its configuration. Moving on, for persistence, we mount two volumes: n8n data for all n8n workflows and credentials, and local files for any additional files we might use in workflows. Finally, we define a bridge network called n8n network. This isolates the container and makes it easier to connect with other services in the future. Once you have configured the file with your domain, save and close it. Now we'll configure Nginx as a reverse proxy for our n8n instance. It serves as a front-facing server that handles incoming requests from the internet. It terminates HTTPS connections, forward requests to the n8n container running on port 5678, and ensures that WebSocket connections and long-running workflows are handled smoothly. Let's start by installing Nginx. Once installed, we need to create a server block for our domain. Here's the configuration we will use. Let me quickly break this down. We'll listen on port 80 initially for HTTP, and Nginx will later handle the redirect to HTTPS. Server name matches our domain so that Nginx knows which request to process. These proxy headers preserve the original client information and protocol, which is crucial for logging, webhooks, and secure connection. The proxy buffering header ensures that real-time WebSocket connections used by n8n work reliably, whereas proxy read timeout and proxy connect timeout settings are extended to 300 seconds and 75 seconds respectively to accommodate long-running workflows that may take time to process. Once you are satisfied with the configuration, save the file and exit from it. Next, we go ahead and enable the site. Further, let's test the configuration for syntax errors. Now that the test is successful, we can reload Nginx to apply the changes. Moving on, let's configure Firewall to allow both HTTP and HTTPS traffic. Finally, we secure our setup with HTTPS using Certbot and Let's Encrypt. First, let's install Certbot and the Nginx plugin. Next, we request a TLS certificate for our domain and alongside provide an administrative email. Certbot automatically updates Nginx for HTTPS and configures automatic certificate renewal. To verify this, perform a dry run. A successful dry run ensures that our n8n instance is now fully secured with HTTPS, supporting real-time workflows with reliable connectivity and automatic certificate management. Finally, that our Nginx reverse proxy and HTTPS are configured, let's start the n8n container using Docker Compose. Once the container is running, let's quickly check its status to ensure everything is up and healthy. Now that we have confirmed, let's open our browser and visit the domain to access our dashboard. The first step is to create an admin account. For that, enter your email, name, and a password and click on Next to get onboarded. Once you log in, the dashboard will look something like this. You can straight away go to templates from this menu and explore over 5,000 workflow automation templates and pick the one you would like to try. Or simply navigate back to the dashboard and create your own custom workflows. Today, let's build one from scratch. For that, click on Create Workflow and start by giving it a meaningful name. For example, we'll call ours Leads Processing Pipeline. Let's begin by adding a webhook trigger node. For that, click on this plus button and search for webhook in the search bar and select the first option from the results. Here, change the HTTP method to post and set a custom path like contact. Once configured, a webhook URL will be presented to you similar to what is shown here. Make sure you copy the production URL. Let's go back to our workflow overview. To add another node, click on this plus button again. This time around, we'll go with set node to extract and fetch all incoming webhook data. Click on add field to start mapping fields for name, email, message, and timestamp. These values will be captured from the incoming post request and formatted for downstream nodes in the workflow. Let's head back to our canvas. Now we'll add a Gmail node to send notification emails. We'll start by creating a new credential. For security, we'll connect using OAuth 2. As a prerequisite, you will need a Google Cloud project and OAuth 2 credential to proceed with this method. While setting up, provide this redirect URI when prompted. Once done, feed the generated client ID and client secret values. You can even restrict the domain if needed. To authorize access, click on Sign in with Google. Once the account is connected, close this modal. Now in the Gmail node, set resource to message, operation to send, provide a recipient email, give a subject line, select the email type, we'll go with HTML, and finally input a message. I can show the expanded view here and it looks something like this. Once all the fields are configured, let's save the changes. Once everything is ready, activate this workflow. Now to test the webhook, you can use Postman, Hopscotch or even curl command. As a first step, click on execute workflow and then switch to the Hopscotch window to send a post request to the webhook URL with a sample payload. Let's hit the API call and just like that, you can see that the workflow has started. Let's go back to our n8n dashboard and as you can see, the execution was successful. We can further head to executions to review the flow and see the output of webhook, our set node and our email node. To solidify our execution, let's also open the recipient's email inbox. As anticipated, the email appears exactly as configured, demonstrating real-time workflow automation in action. And that's how you can build and execute n8n workflows on Vultr. With this foundation, you can extend the automation workflow to connect different services, APIs, and AI agents to streamline your business processes in real time. To learn more and explore advanced features, refer to the n8n official documentation and our supporting reference guide to self-host n8n on Vultr, both of which are provided in the description of this video. To summarize, we have seen how n8n enables seamless automation across multiple systems, handle real-time data transformation, and trigger action based on workflow logic, all while giving full control over your data. We highly encourage you to deploy n8n on Vultr and experiment with building your own workflows. To help you get started on Vultr, claim $250 in free credits on a new account using the promo link attached in the description below. If you have any queries or want to share your experiences, visit the Vultr Community Forum. Thank you so much for joining today's session. We look forward to seeing the automated workflows you build in action.